Hello everyone, hope you all are doing good. Today we will be discussing some questions from numbers. Some of you might have already solved these question sets. If you're having any doubts, you can just refer to that particular question. Those people who are yet to solve these question sets, please do try solving it first and then check for the answers. The PDF has already been shared in the group. Let's start. Question number 1. It's based on a previous place and model question. So here you're asked to find the unit digit, okay? Unit digit of what? Let's check. So there is a 7-digit number ending in 9, perfect. It is raised to an even power, greater than 2000. Now that doesn't matter. So the thing that is important over here is 9 raised to even. We know 9 raised to even will give you 1 at the unit place, right? Unit digit will be 1. 9 to the power odd is 9, 9 to the power even is 1, perfect. Now there is another number 17 that is raised to a power which leaves a remainder 1 when divided by 4. Be careful over this. So what do we do for unit place? Yeah, we have a number, we might be having some power over here, let's say 17 to the power a. We take the exponent or the power part divided by 4 and see the remainder for cyclicity. Am I right? In case of 7, the cyclicity is 4, so we divide the power by 4 and see the remainder. Here they have directly given the remainder as 1, which means it falls in the first cycle, or let's say we can raise the 17 to the power 1 and unit place of 17 to the power 1 is 7. Now, this person is multiplying these two numbers. So 1 into 7, answer will be 7. That's all. So option is the answer. I hope it is clear. So let's move on to the second one. Question number 2 is based on reminder concept. It's a basic level question. Before solving this one, let's try this question over here. So a number divided by 117, remainder is 23. Find the remainder when the same number is divided by 13. It's basic level question. There are multiple approaches for this question. So one basic level approach is you can assume any number which when divided by 117 gives a remainder 23. This should be the smallest number, or let's say if the quotient is 1, 117 into 1 will give you 117 plus 23 will give you that number which gives a remainder 23 when divided by 117, isn't it? Is that clear? See, 117 into 1 gives the first multiple of 117. Plus 23 will give you such a number that gives a remainder 23 when divided by 117, isn't it? So 140 is the number. Now this concept is based on the basic rule over here. Dividend is equal to divisor into quotient plus remainder, which you already know, isn't it? So divisor is 117, quotient we assume it as 1. You can go with 2, 3, 4, 5, etc. That's up to you, plus remainder 23. So as for this, we'll get the number to be 140. Now the same number has to be divided by 13 and we need to find the remainder. So 140 by 13 is very easy now. 13 tens are 130. Remainder will be 10. Perfect. Now just observe the remainder over here. That is 23. Now if you divide this 23, the given remainder is 23. If you divide this 23 by the divisor 13, what will be the remainder? Perfect, 10, isn't it? Which means the shortcut for these models is observe the remainder given in the question divided by the asked divisor to get the answer. Why that works? Because if you observe this, dividend is the number. You're asked to divide this dividend by 13, isn't it? Which means as for this by 13 and this by 13. So 117 by 13 will never give you a remainder. Why? Because 117 is a multiple of 13. Now the only possibility of a remainder case is over here. So that's why this shortcut works. 23 by 13 gives you a remainder as 10, isn't it? So answer will be 10. So without even assuming a number, you can find the answer for these kind of questions. Now, the test comes here. Let's come to our question over here. To observe the question over here, let me clear all these things. Perfect. To observe the question over here, go to the options. You can see an option like cannot be determined, isn't it? So whenever you're having a cannot be determined option, check whether the given divisors are related. Now, if you observe the example question over here, 117 and 13 were the divisors. Both are actually related. How? 13 is a factor of 117, or let's say 117 is a multiple of 13. So that is why that shortcut worked over there. Clear? So if these two are actually related to each other, the shortcut is take the remainder, divide by the divisor and find the answer. 43 by 36 would have given you the answer as 7. But here, 156 and 36 are not related. So the answer will be yes, cannot be determined. Why? Because if I assume quotient to be 1, I will get one type of remainder. Now, if you're going to assume quotient as 2, 3, etc., you'll be getting different reminders. But in this case, irrespective of whatever the quotient is, the reminder will be same in each case. Why? Because these two are related. Clear? Yeah, very basic thing. So answer for question number 2 is cannot be determined. Let's move on to the next one. Question number 3 is again based on the previous logic. So we are given two numbers A as well as B. It is divided by divisor D. Now in each case you are having reminders 18 and 11. So now after that what is done? Yes, if the sum of the numbers is divided by the same divisor, you get a reminder as 4. You have to find the divisor D. So these kind of questions can be solved through options. Now the logic is two numbers. So those two numbers are divided by the same divisor, isn't it? And you are getting reminders. Now addition of those two numbers, which means you can add the reminders of those two numbers and divide by the divisor and find the reminder. That's the logic over here. So if you add the reminders given in the question, that gives you 29, isn't it? 18 plus 9 is 29. That divided by the divisor gives you reminder as 4. Now from the options, check which number will give you the remainder as 4 if you divide that by 29. 21, 29 by 21 will not give you 4. If you observe, you can see the option D, that is 25. 29 by 25 gives you remainder as 4. So answer is 25. Now for those people who haven't understood, I will explain the basic method. So the number A is there, divisor is D into some quotient plus remainder is 18. Now we are having the number B. Again, divisor is same, quotient might differ, remainder is 11. Now, A plus B means we are adding these two, which means we are adding the right hand side. So that becomes C. Divisor into Q1 plus divisor into Q2 plus 18 plus 11 is 29. Is that clear? Now, A plus B is divided by D, isn't it? Which means this you are going to divide by D, this you are going to divide by D, and this also you are going to divide by D. Now, see. This D and D will be cancelled, which means you won't get any reminder over here. Will not get any reminder over here. The only possibility of a reminder is 0. Now they have mentioned the reminder to be 4. So if you divide 29 by D, you should get reminder as 4. Now observe the divisor from the given options. 29 by 25 gives you reminder as 4. Clear? So this is a shortest approach. If you understand the logic, you can solve this question within some seconds. Question number 4 is based on divisibility rules. This is one kind of question which gets repeated in most of the competitive exams. So let's solve this question. We will discuss two methods. One is the shortest approach, other one is the basic logical method. So let's go with the shortest approach for this particular question. So observe the divisor 84. So least number that should be added to this one, so that is a multiple of 84. Observe the options. Let's go with the option elimination approach. So we can discard two options from here. Which are? Yes, perfect. This one and this one. Why? Because these two numbers are greater than 84. So for the moment, let's discard those two numbers. Because the least number should be less than 84, isn't it? Now we are left with 57 and 27. Now, if you observe the number 84, you're able to recognize that 84 is a multiple of 4, 3 and 7. Based on the prime factor form, 2 square, 3 and 7. Then it will be very easy to find out the answer. Let's check how. You know the divisibility rules of 4, 3 and 7, isn't it? If you go with 3, the number should be, the sum of these should be a multiple of 3. You observe 8, 9, 6, 1 is a multiple of 3. So the number that should be added should also be a multiple of 3. 57 and 27 both are multiples of 3. So we cannot eliminate any option through 3. Now let's go with 4. What does divisibility rule of 4 say? Yes, the last two digits should be multiple of 4. So 8961 plus 57 will give you 18 as the last two digits, isn't it? That is not a multiple of 4, which means 57 is also eliminated. So our answer has to be 27, but let's check. 8961 plus 27. Yes, 88 is a multiple of 4, which means answer will be option C. So if you're able to observe these things, if you're having some rational thinking, you will be able to eliminate options very easily and you will be able to solve this question in some seconds. Now let's discuss the logical approach, because in certain questions you might need the logical approach to solve the question. So 8961 to divide it by 84, find out what you get as the remainder. Let's see. 1 time 84 is 5. So 6 is written over here. It doesn't go in 84. We need this 1 also, which means we'll put a 0 over here. Now Our focus should only be on the remainder. Don't worry about the quotient part. So 84, 87s are 560, right? So 84 into 7 will give you an answer greater than 560, which means 84 into 6 might give a number. So 6 4s are 24, carry 2, 8 6 are 48 plus 2, 55, not 4. Now remainder will be 57. We are asked to find what least number should be added with 8961, isn't it? So 57 is the remainder over here. So if you add one more 27, you will get 84, isn't it? Which means find the difference between this divisor and the given remainder, that is 27. That is the number to be added. So if you're asked to find the least number that should be added, just find the difference between the divisor and the final remainder which you got. That gives you the answer 27. Now, if you're asked to find least number that should be subtracted. In that scenario, just subtract the remainder that you get in the final step, which means the question was least number to be subtracted, the answer would have been 57. So in this question, the answer is 27. Here, over. Let's move to the next question then. Question number 5, based on remainder. So 7 power 102 divided by 2402, what is the remainder? So there are multiple methods. Let's go with the plus 1 minus 1 logic initially. 7 power 102 by 2402. So if you're able to make the numerator as 2403 or 2401, we can go with the plus 1 or minus 1 remainder case, isn't it? Now, if you know that 7 power 4 is 2401, then you will read the answer very easily, which means you can convert this as 7 power 4 whole power, yes, power 25. That gives you 7 power 100 into remaining is 7 square divided by 2402. Now this 7 power 4 is nothing but 2401. So 2401 divided by 2402 will give you the remainder as minus 1. Perfect. Isn't it? Yes. Positive remainder is 2401, negative remainder is minus 1, which means this term will be, the remainder will be minus 1 to the power 25 into 7 square is 49 by 2402 again. So minus 1 to the power 25 will give you again minus 1. So minus 1 to 49 gives you minus 49. So as per this, minus 49 is what you get as a remainder. Now, we know that we never express the final answer in negative. Negative reminders are just used for calculation purposes, calculation shortcuts. So, how to read the final answer? Yes, perfect. Observe the divisor, that is 2402, isn't it? Now, subtract the absolute value, that is minus 49. That gives the answer as 2353, right? So, answer will be option C. Very easy. Just go with this logic. This might be easy for this question. So let's move to the next one. So let's go to question number 6. It's also based on previous placement model. So there is one 120-digit number. It's found by using the first x natural numbers starting from 1. Now we are dividing that 120-digit number by 8. You're asked to find the remainder. So we know the divisibility rule of 8, isn't it? Yes, last 3 digits. So if you're having the last 3 digits, divided by 8 and find the remainder, that's all. Now to find the last 3 digits, what should be done? Yes, exactly. See, we are making the number using our natural numbers, consecutive natural numbers. It's very easy. 1 to 9. We are having single digit numbers, isn't it? Which means 9 digits we will be using from 1 to 9. So in this 120 digits, if we subtract this 9 digits, we will be having the triple 1 digits, isn't it? Now, why are we subtracting this 9 digits? We'll come to know. So, after 9, we'll be having 2-digit numbers from 10 up to 99. Now, from 10 up to 99, how many numbers are there? 90 numbers, perfect. Which means each number is having 2 digits. So, for 90 numbers, we'll be having 180 digits. Am I right? So, we only need 120 digits, and out of this 120, the first 9 digits are framed by our first 9 numbers, isn't it? So remaining 1 digits will be framed using our 2-digit numbers, isn't it? Now in this 1 digits, how many numbers do we need? Yes, divided by 2 now. Yes, 55. We're using 55 numbers, 55 2-digit numbers. You will be having 110 digits, isn't it? We just need 111 digits. Why? Because the other 9 digits are formed by the first 9 numbers which are having single digits. So let's check how many numbers are required for this. From 10, we need 55 numbers. which means from 10 up to, yes, 64. From 10 up to 64, we will be having 55 numbers. This will give us 110 digits, but we require 111 digits, which means 64, which means 1, 2, 3, 4, etc. See, our number will be 1, 2, 3, 4, etc. up to 63, 64. This will end up in 119 digits. 110 plus 9, that is 119 digits. We need 120 digits, right? So next number will be 65. In that 65, we just need to use 6. So our last 3 digits will be 646. Now 646 divided by 8. Remainder will be 6. 640 is a multiple of 8. Then 646 by 8 will give you remainder 6. Option A is the answer. Clear now? Comment. So question number 7. Again based on reminder. So you're having exponent numbers over here divided by 74. So if you observe the powers are same, so we had some reminder theorem, isn't it? A power n plus b power n is divisible by a plus b when n is odd. If you observe the power here, the power is even number, isn't it? But can we make it odd? Yes, definitely we can make it odd. Let's take like this 5 square power 35 plus 7 square power 35. Now 5 square is 25 and 7 square is 49. 25 plus 49 will give you 74, which means this divided by 74 will give you remainder as 0. 0 remainder. Why? Because a power n plus b power n is always divisible by a plus b if n is odd. So 35 is an odd number, which means it's divisible by 5 square plus 7 square, or let's say 74. So answer will be option B, 0. Question number 8. It's actually a previous placement question. It's a very, very easy question, isn't it? We're asked to find the number of factors. So there is a number n. The number of factors is expressed like this. That is a square into b into c. A into a means a square, isn't it? And a, b, c are all distinct prime numbers. So factors of n. What should be done? Yes, take the power, add 1 to it. So 3. The power is 1 over these digits or b and c. So add 1 to it, give you 2. Again, add 1 to it, give you 2. 3 into 2, 6 into 12. Answer will be 12. So option B is the answer again, 12. Very easy question. Question number 9. To find the number of zeros towards the end of 125 factorial, trailing zeros. We have already discussed these logics, concepts. So 125 factorial, we know to get a 0, we need a multiplication pair of 2 and 5, isn't it? So our aim is to find out how many multiplication pairs of 2 and 5 are there in the given number. So in factorials, we know that the number of 2, so rather say multiples of 2 will be more than the multiples of 5. So what we do is we find the highest power of 5, or let's say how many 5s are contained in this factorial, 125 factorial. So 125 by 5 will give you 25 as the quotient. So we keep on dividing till our quotient becomes less than 5. 25 by 5 will give 5 as the quotient. Now 5 by 5 will give you 1 as the quotient. Add all the quotients. So 25 plus 5, 30 plus 1, 31. The same method or the same logic in another approach, another way, 125 by 5 plus 125 by 5 square plus 125 by 5 cubes. That is the highest power of 5 with 5 cube. So 125 by 5 gives you 25 again. This gives you 5. This gives you 1. Add all those. You get 31 as the answer. Option D is the answer. Question number 10. Again, a basic level question. So you're asked to find number of prime factors in the given expression. So you know what are prime factors, isn't it? You need to find out how many times that prime number exists in the given number. Now observe the given term or given expression. It's actually 11 is a prime number, but 6 and 35 are not prime. So we need to ensure that the given numbers are in prime form. So 6, it is 2 into 3, isn't it? So 2 into 3 whole power 7 into 35 cube is nothing but 5 into 7 whole power 3 into 11 power 10. So you can just add the powers, that is 2 power 7 plus 3 power 7 plus 5 power 3 plus 7 power 3 plus 11 power 10. 7, 14, 17, 20 plus 10, 30. Answer will be 30. Option is the answer. That's all. See, observe, you know that you have 2 prime numbers over here. So 7 plus 7 is 14. Again, 35 also has got 2 prime factors, 5 and 7. So 3 plus 3, 6. 11 is in prime form. Answer will be 30. The question number 11 is also based on previous model. So this is actually based on the basic concept of factors. So if you're thorough with the factors concept, you'll be able to answer this in a fraction of a second. Or else what you might do is you will go through the options and solve each option. That will take time. So let's check the question. So you are given a number p. Total number of factors is given to be x. Now, if x is an even number, which among the following can be the value of p? Which means to find the total number of factors, you will get one number, isn't it? Number of factors will be expressed as a number. That number has to be an even number. If you don't know the logic of those small things, what you'll do is you will find out the number of factors of each of these options and you will get the answer. But it will take time. Now, if you observe, let's go with an example, okay? Observe the number 9. Number of factors, 9 is 3 square. Number of factors will be 2 plus 1, that is 3. If you observe 36, it's a perfect square number. It's again 2 square into 3 square. Observe the number of factors for this 36. 2 plus 1, 3. 2 plus 1, 3. 3 into 3, 9. Which means the number of factors will be an odd number for all the perfect square numbers. Why? Because the power has to be an even number to get a perfect square number. So our logic or the shortcut to find number of factors is power plus 1. So even number plus 1 will give you an odd number. So multiplying multiple odd numbers will always end up in an odd number. So number of factors for a perfect square number will always be an odd number, which means the non-perfect square numbers will always have number of factors to be an even number. Clear? So we need to identify such an option which is a non-perfect square number. 144 is a perfect square, 361 is a perfect square, 576 is also a perfect square. 288 is the option which is not a perfect square, so the answer will be 288. No need to find out number of factors. Now, question number 12. It's a level up question. So, we are given one number in this format and we are asked to find the remainder when this is divided by 70. So, there are multiple ways over here. One way, let's combine 16 cube and 19 cube, 17 cube and 18 cube. Now, don't go and find the answers of 16 cube, 17 cube, 18 cube and 19 cube. Okay, if you know the answers of the cube by heart, you can try, but again, you can go with other approaches. So, 16 cube plus 19 cube by 70. Okay, one term. The next term we are combining 17 cube and 18 cube by 70. We'll see why we are doing like this. So we know a power n plus b power n is divisible by a plus b if n is odd, isn't it? Now see, n is odd, which means 16 plus 19 gives you 35. So this expression is a multiple of 35. Similarly, this expression is also a multiple of 35, isn't it? Now 70 is 35 into 2. Now, one more thing. So we know these two parts are multiples of 35. Now, if you're able to prove that these two sums will give you an even number, then definitely this expression is a multiple of 70. Clear? Now, 16 power 3. What will be the unit place of 6 power 3? It will be 6, you know. Now, 9 power 3 will be, yes, 9 power odd number will give you 9. So, 9 plus 6 will give you an odd number. Perfect. Let's observe these terms. 7 power 3 will give you an odd number, isn't odd number? This will give an even number. So, odd plus even will give you again odd. Now, if you add two odd numbers, which means this is an odd number here. So, this expression will give unit digit as odd. And this expression will give again unit digit as odd. So, if you add two odd numbers, what you'll get? You will end up in an even number, which means the addition of this full expression will be an even number. Now, these are multiples of 35 as well as these are even numbers, which is multiples of 2. So, it's actually an even number as well as multiple of 35, which means a multiple of 70. So, answer will be option C. Clear? 0 will be the remainder because this is a multiple of 70. If it's not clear, please rewind and hear it again. Now, there is one more logic over there. Observe the numbers. They are in AP. AP, isn't it? They are in AP. So, if they are in AP, then, and if the power is an odd number, power is an odd number, then the number of the form a power n plus b power n plus c power n plus d power n will be divisible by a plus b plus c plus d, provided a, b, c, d are in A3 as well as the power is odd. So power is odd, so 16 plus 17 is actually 33, 51, 70. So divisible by 70. So answer will be option C, 0 remainder. Clear? Perfect. So question number 13, you're asked to find the difference between number of odd factors of 1521 even factors of 76. So 1521, let's factorize it. So it's a multiple of 9. We can observe the number is a multiple of 9. If you know the square root value, it's actually a perfect square number, okay? If you're able to observe it as a perfect square number, you'll be able to visualize the square root value. If not, we can factorize it. Now don't go with the school method of like this one. So practice you can do this. After that, apply the divisibility rules and rational thinking to find out the factors, okay? 5, 7, 8, 9, multiple of 9. So 9 ones are 9, remainder is 6, 62, 9 6 are 54, remainder will be 8, so 9 into 169, or as I say, 1521 is nothing but 3 square into 13 square. It's actually 39 square, okay? 1521. Now similarly for 676, it might be 9, it has 26 square, isn't it? So 670 is 26 square, which means 670 can be written as 26 is 2 into 13, 2 square into 13 square. Now, odd factors of 1521. Now, if you observe the number 1521, it will have only odd factors, which means number of factors will be equal to odd factors. So, number of factors will be 3 into 3, 9. So, number of odd factors will be equal to total number of factors, that is 9 for this number. Now, for this number, 676, you are asked to find number of even factors, right? So, what is to be done? Yes. Take the even numbers power as such into number of odd factors, that is 2 plus 1. Odd factor. So 13 is an odd number, isn't it? So power plus 1. That's the method to find, or shortcut formula to find number of odd factors. So 2 into 3 will give you 6. For us to find difference between the number of odd factors and even factors, 9 minus 6, answer will be 3. Now question number 14. So it's based on the consecutive natural numbers thing. So let's make this consecutive positive this, okay? That will be more easier to solve. Consecutive positive values, which means natural numbers. So we are asked to find the value of n. Now these kind of questions can be solved using the formula approaches, but the best way will be to go with assuming numbers. Let's go with the first 3 natural numbers. 1 plus 2 plus 3 is 6. The next 3 natural numbers will be 4 plus 5 plus 6. Then will give you 15. Find the difference now. The sum of n consecutive integers are 900 less than next n consecutive integers, which means the difference between these two is given as 900. We don't know how many numbers are taken. Now, to understand the shortcut, we are going with the basic example over here, okay? Now, difference between these two is 9, isn't it? Now, let's go with one more set to understand that shortcut, which we are going to apply. Let's go with the first 4 numbers. So, 1 plus 2 plus 3 plus 4. What's the sum? 10. Perfect. Next 4 natural numbers will be 5 plus 6 plus 7 plus 8. Sum 8 plus 1, 15, 20, 26. Now, difference between these two is 16. 10 is 16 less than 26. Now, observe the differences. When you had 3 numbers, the difference is 9. When you have 4 numbers, the difference is 16. Any connection? Yes, perfect. So, n square is the difference. N square is the difference. Which means difference is 900. 900 is nothing but n square. So n will be root of 900. So answer will be 30. Option A. Clear? Perfect. Question number 15. An important model as well as like a higher variant model. So highest power of 40 which can completely divide 4000 factor. Same logic as trailing zeros. There actually we found the highest power of 5. So here you are asked to find highest power of 40. Now the basic approach is convert this number. It's a composite number. Now convert that into prime form. That is 2 power 3 into 5. 8 5 is 40. Now highest power of this and highest power of this will give you the answer. That is the logic is to find out the highest power of this one as well as the highest power of this one. The minimum number will give you the answer. If you observe the powers of 2 or the multiples of 2 will be greater in 4000 factorial than the number of or the multiples of 5, isn't it? If you want, you can check it separate. So Our aim is to find the number of 5, so the highest power of 5 in 4000 factorial for this particular question. Okay, so 4000 by 5. Find the quotient. How much? 800. Now keep on dividing the quotient. That also will give you the answer. 800 by 5 will give you 160. We'll go over here. So 160 by 5 will give you 32. Now 32 by 5 will give you how much? Yes, 6 5 is 30. Don't worry about the remainder. Now 6 by 5 will give you 1. So let's see the quotients and add 800. So 960, 990, 992, 998, 999. Option C is answer. So we had already discussed the basic concept in the class. That's why we just went with the approach over here. Clear? So answer will be 999. Option C is the answer. The question number 16, a higher variant question it is. So we are having a natural number n, successive division. Now, if you don't know successive division, please listen. So n is divided by 4 initially. Okay, you will get some quotient. Let's say it is q1, and the remainder you get is how much? 2. Now successive division means now this quotient is taken. Okay, that quotient q1, I'm going to write over here q1. Now this is divided by the next divisor, that is 5. Again you will end up in some quotient. Let's call it q2, and the remainder you get is 4. Now again one more divisor is there, that's 6. Now you will take this quotient q2 divided by 6, you will get another quotient, and the remainder obtained is 5. Clear? This is what the logic of the question is. Now the same number is divided by 12 and 10. What is the sum of the remainders obtained? That is the question. So what we do is we will start from the last step. Now our last step is this. Okay, this was the last step, isn't it? The first step was this, got a quotient, that was again divided, got another quotient, that was again divided. So which means this q2, our number q2 now, that is equal to 6 into some quotient plus remainder, isn't it? Isn't it? Yeah. Now again assume this q3 as some number 1, 2, 3, etc. Anything you want. Let's go with 1, the basic number 1. So 6 into 1 is 6 plus 5, 11, which means the q2 will be 11 if you assume q3 to be 1. So q2 is 11. Clear? Now where will this q2 come? Over here. Again we will get the value for q1 now. q1. How will you get value for q1? q1 is nothing but 5 into q2 plus 4. See, once you understand this, you will be able to solve this very easily. For explanation part, we are taking some time because there might be some people who might not know how to apply the logic. That's why. Now, q2 is already 11 as per our assumption. So, 5 into 11 plus 4. 11 5s are 55 plus 4, 59. So, we got the value of q1, that is 59. Now, we can find the number easily. 59 into 4. Number is nothing but quotient into divisor plus remainder. 59 into 4 is 236 plus 2, 230. So, number is 238. If it is clear up to this much, then it will be very easy to solve. Okay, so 238 is our number. Now we will solve it over here. So 238, you are going to divide 238 by 12. So 12 ones are 12, 23 minus 12 is 11, 118. So 12 nines are 108. So remainder will be 10. The first remainder is 10. Now successive division, which means take this quotient 19 divided by 10 and find the remainder. 10 ones are 10, remainder will be 9. Just to find sum of remainder, that is 10 plus 9. Answer will be 19. Option is the answer. Is that clear? If not, please rewind and here. So we started from the back, or we back work the question from this. So it's very easy. Take the divisor 6. Quotient is 1. Okay, assume quotient is 1. 6 into 1 plus the remainder. 6 into 1 plus 5, 11. The first step is over. Now 11 into 5, 55 plus 4. 59. Second step is over. Now 59 into 4, 236 plus 2, 238. The number is 238. Assume number is 238. And then do this one and you'll get the answer. Clear now? Perfect. So question number 17. We're asked to find in how many ways can we write this number as product of two distinct natural numbers. This is also another repeated model question. Okay. So the logic is find the total number of factors that will give you the different type of numbers. Now, product of two numbers means we need two numbers at a time, which means total number of factors by 2 will give the answer. Clear? Now, let's find the total number of factors of 196. Again, 196 is a perfect square number. 14 square. If we know the perfect square is from 1 to 25, it will be very easy to certain calculations. So 14 square is 2 into 7, right? 14 is actually a composite number. So 2 square into 7 square. Isn't it? 2 into 7 ka whole square is 2 square into 7 square, which means total number of factors will be 3 into 3, 9. Now, we cannot divide 9 by 2, isn't it? Then we give a decimal answer. We can divide, but we give a decimal answer. So, in case of perfect square numbers, whenever you end up in an odd number, in perfect square numbers, slight change in formula. Total factors minus 1 by 2. Why? Because we are having one number as common, isn't it? See, 14 square is 14 into 14. We have only one distinct number in this, isn't it? So, that's why we are subtracting 1 and then divide by 2, which means 9 minus 1 by 2, 8 by 2, answer will be 4. In 4 ways, we can express this number as product of two distinct natural numbers. Answer will be 4 ways. Clear? So, no need to find out the individual factors and then see the combinations. Find the total number of factors by 2 will give you the answer. So, if you're having a perfect square number, we have discussed this logic earlier, isn't it? If you're having a perfect square number, total number of factors will be an odd number. If you're getting an odd number, what should be done? Subtract 1 from it and then divide by 2. That will give you the answer. So, answer will be 4. Yeah. So, I hope all the 17 questions might be clear to you. Questions and the solution part might be clear to you. So, we have discussed some shortcuts in between. I hope you haven't missed the shortcuts. Clear? So, if you're having any better approaches, what I will suggest is you can either post it in the comment, or when we meet next time, you can come up with a shortcut so that we can discuss more about it. We will meet again in the next session. Bye everyone. Take care.